Night of the 15th of November, 1943. Germany did not lose a battle on the front lines. It lost something far more dangerous silently. No bombs were falling, no tanks were burning. Inside a power station near Essen, engineer Friedrich Stahl watched alarms scream and gauges slam into the red. The main turbine was shaking itself apart. Demand had exceeded capacity by a margin that should not have been possible. And in that moment, Stahl understood the truth no one in Berlin wanted to hear. The war was ending not because Germany was running out of soldiers or steel, but because it was running out of electricity. The 15th of November, 1943. Just outside Essen, in the industrial heart of Germany, a power station was fighting for its life. Inside the control room, warning lights flashed without pause. Alarms screamed over one another. Gauges that were never meant to reach their limit slammed into the red and stayed there. Friedrich Stahl, a senior engineer on duty that night, stood frozen as the main turbine began to vibrate violently. Bearings overheated. Steam pressure spiked. The machine was being forced to deliver more power than it had ever been designed to produce. This was not a mechanical failure caused by enemy bombs. This was something worse. The system itself was being pushed beyond its physical limits. Across Germany, factories were drawing electricity at unprecedented levels. Tank plants, aircraft assembly lines, ammunition presses, rail networks, communication hubs, everything demanded power at the same time, without pause, without restraint. The grid had no room left to breathe. There were no reserves, no margin, no safety buffer. Stahl watched the needle dip and recover, then dip again. He understood what the planners in Berlin did not. This was not a temporary overload. It was structural collapse in slow motion. Germany's war economy was not failing because of enemy action alone. It was failing because it required more electricity than the nation could ever generate. Once the power went out, nothing else would matter. To understand how Germany reached this breaking point, the story has to rewind 7 years earlier to 1936, when the war had not yet begun, but the damage was already being done. That year, Adolf Hitler announced the 4-year plan, a radical program designed to prepare Germany for total war in the shortest time possible. Rearmament became the single overriding priority. Speed mattered more than balance. Output mattered more than sustainability. Hjalmar Schacht, the architect of Germany's financial recovery after the Great Depression, warned that the pace was reckless. He argued that the economy, especially its energy infrastructure, could not support such rapid expansion. His warnings were dismissed. Instead, Hitler placed Hermann Göring in charge of the entire rearmament effort, granting him sweeping authority and demanding results at any cost. Factories rose across the Reich. Steel mills expanded. Aircraft plants multiplied. Tank production lines ran day and night. Synthetic fuel facilities were constructed to free Germany from dependence on imported oil. On paper, the numbers looked impressive. Output climbed. Production records were broken. The regime celebrated these achievements as proof that willpower could overcome any obstacle. Almost no one wanted to confront was the hidden requirement behind every success. Every press, every furnace, every lathe, every rail switch, every radio transmitter required electricity. And Germany's electrical system had been designed for a peacetime economy, not for permanent, full-throttle mobilization. Mid-1930 seconds, Germany produced roughly 18 billion kilowatt-hours of electricity per year. It was a modern, advanced system, built with coal-fired plants, hydroelectric stations, and early thermal facilities. But it had limits. Those limits were fixed by physics, geography, and construction timelines. You could push the system harder, but you could not expand it quickly. Rearmament accelerated. Electrical demand rose faster than new capacity could be built. Power plants ran continuously, without downtime for maintenance. Engineers quietly adjusted tolerances and ignored warning signs. New industrial projects were approved without any realistic accounting of where their electricity would come from. Germany was building weapons at a pace its power grid could not sustain. And with every new factory brought online, the collapse crept closer unnoticed by leaders who believed that determination could replace mathematics. By the time Albert Speer took control of armaments production in 1942, the problem was no longer theoretical. It was already embedded into the system. Speer was an efficient administrator, far more disciplined than the men before him, and under his management, German weapons output actually increased despite Allied bombing. But this apparent success hid a fatal contradiction. You cannot organize your way around physics. You cannot manage electricity into existence. Germany's power plants were already running at maximum output. Coal-fired stations burned day and night. Hydroelectric plants operated at full seasonal capacity. There was no reserve left to tap. Building new power plants would have required years, massive quantities of steel, copper, turbines, generators, and skilled labor, the exact same resources being consumed by tanks, aircraft, submarines, and artillery. Every additional weapon demanded more electricity to build. Every effort to expand weapons production made the power shortage worse. And the most devastating drain of all came from Germany's decision to pursue energy independence through synthetic fuel. Synthetic fuel plants converted coal into liquid fuel using complex chemical processes. These facilities were among the most electricity-hungry industrial installations ever built. By 1942, they were consuming an estimated 1/4 to 1/3 of all electricity generated in Germany. Vast amounts of power were being burned simply to produce fuel that was then required to move weapons, run factories, and generate more electricity. It was a closed loop with no escape. Power station managers knew. Internal reports documented overloads, overheating equipment, and declining reliability. But in a system where bad news was dangerous, those warnings rarely reached the top. Admitting limits meant admitting failure, and failure was ideologically unacceptable. The grid was pushed harder. Safety margins disappeared. Maintenance was deferred. Equipment aged faster than it could be replaced. Germany's war economy continued to grow on paper while its electrical foundation quietly cracked underneath it. In 1943, the system was no longer fragile. It was unstable, and once the Allies began targeting power plants, substations, and synthetic fuel facilities directly, collapse was no longer a possibility. It was inevitable. By 1943, the Allies had identified what Germany itself refused to face. The electrical grid was the nervous system of the war economy. Destroy it, and everything else would fail on its own. Tanks would sit unfinished. Aircraft would remain half-built. Railways would stop. Communications would go silent. You didn't need to conquer factories if you could simply turn them off. Here, Allied bombing strategy shifted. Instead of focusing only on weapons plants, raids began targeting power stations, substations, transmission lines, and most critically, synthetic fuel facilities. In late July 1943, Hamburg became the proving ground. The firestorm that engulfed the city did more than kill tens of thousands. It knocked major power generation offline. Entire industrial districts went dark. Production stopped instantly. Not because buildings were destroyed, but because electricity was gone. Recovery took months, and while repairs dragged on, demand elsewhere continued to rise. There was no slack in the system to absorb the damage. Every bomb that hit a transformer or turbine forced brutal choices. Power had to be rerouted. One factory went dark so another could run for a few hours. Civilian areas lost electricity so weapons plants could operate at reduced output. In 1944, the Americans concentrated their efforts on synthetic fuel. The logic was devastatingly simple. No fuel meant no movement. No movement meant no war. Repeated bombing raids crippled the plants at Leuna, Merseburg, and other sites. As fuel production collapsed, the electrical crisis intensified. Coal deliveries fell. Power stations lost inputs. Electricity generation dropped further, feeding back into the collapse. Winter, Germany was trapped in a downward spiral. Less electricity meant fewer weapons. Fewer weapons meant less ability to defend infrastructure. More bombing meant less electricity still. Engineers were ordered to meet impossible quotas and blamed when mathematics refused to cooperate. Factories received power for hours at a time, then shut down without warning. Production became chaotic and inefficient. Skilled workers stood idle beside silent machines. Assembly lines stopped mid-process. The war economy that had once boasted relentless output was now flickering, unstable, and visibly failing. Germany was no longer fighting a conventional war. It was rationing electricity in a collapsing system and losing ground with every blackout. By late 1944, the electrical crisis had fused with the fuel crisis into something Germany could no longer control. Power stations were damaged or running on emergency margins. Transmission lines were repeatedly cut. Coal deliveries were disrupted. And winter drove civilian demand higher at the exact moment military demand peaked. There was no solution, only rationing. Decision became a loss. Power the tank factories, and cities went dark. Power the rail network, and weapons plants shut down. Power the U-boat yards, and synthetic fuel production collapsed. Engineers were ordered to supply electricity that did not exist. When they failed, they were accused of incompetence or sabotage. But this was not mismanagement. It was arithmetic. Early 1945, weapons production no longer failed because of bombs alone. It failed because machines could only run for a few hours before power was cut and rerouted elsewhere. Factories operated in bursts on, then off, then on again, destroying efficiency. The advanced weapons Germany hoped would reverse the war never arrived in meaningful numbers. Jet fighters sat unfinished. Submarines left shipyards without fuel to sail. Tanks rolled off assembly lines, only to be parked and abandoned. Speer later admitted that the electrical collapse convinced him the war was truly lost. Not because the armies were defeated, though they were, but because the infrastructure required to sustain modern war no longer existed. Germany could still order weapons. It could still demand production. But it could no longer power the machines that made them. In the final weeks, the grid ceased to function as a system at all. Isolated pockets of electricity flickered briefly, then vanished. Cities went dark. Communications failed. Transportation halted. When Berlin fell in May 1945, it was not just a political capital in ruins, it was a city without reliable electricity. It did not lose the war in a single battle. It lost it slowly, silently, as its electrical system collapsed under demands it was never built to survive. And once the power was gone, the war was already over. The collapse of Germany's electrical grid during World War II offers one of the clearest lessons in modern history about how wars are not decided solely by courage, ideology, or battlefield tactics, but by systems. More specifically, by the limits of those systems. Germany did not lose the war simply because its armies were defeated or because its enemies were stronger in combat. It lost because it attempted to wage a fully industrial, mechanized war on an infrastructure that was never designed to support it. Part of this failure was a misunderstanding of what modern warfare actually requires. 20th century war is not powered by slogans or speeches. It is powered by electricity. Every tank hull pressed from steel, every aircraft engine machined to tight tolerances, every radio transmission, rail junction, radar station, refinery, and assembly line depends on a continuous, stable flow of electrical power. Germany built a war machine that consumed electricity at an accelerating rate while treating electrical infrastructure as a secondary concern. That imbalance proved fatal. Nazi leadership believed that production could be increased indefinitely through willpower, discipline, and organizational pressure. When shortages appeared, the response was always the same: demand more output. When systems strained, the answer was to push them harder, This approach worked in the short term. German production figures rose dramatically between 1942 and 1944, even under heavy bombing. On paper, this looked like success. In reality, it masked a growing structural failure. The system can operate indefinitely beyond its design limits. Power plants have maximum output. Transmission networks have finite capacity. Turbines, transformers, and generators degrade when pushed continuously without maintenance. Germany's electrical grid had been built to serve a peacetime industrial economy, not a permanently mobilized war economy, running at full throttle without pause. The decision to prioritize weapons over infrastructure meant that expansion of generating capacity was always postponed. Years passed. The gap between demand and supply widened, and eventually there was no margin left. The most important lessons from this collapse is that infrastructure cannot be improvised under pressure. You cannot decide in 1943 that you need more electricity in 1944 and expect the problem to be solved. Power plants take years to plan, build, and integrate. They require massive quantities of steel, copper, skilled labor, and specialized machinery. By the time Germany recognized the scale of its electrical shortfall, it was already too late. The resources required to fix the problem were being consumed by the very war effort that depended on electricity. The synthetic fuel program illustrates this paradox perfectly. Germany pursued coal to liquid fuel production to achieve strategic independence. On paper, it was a rational decision. In practice, it created a self-destructive loop. Synthetic fuel plants consumed enormous amounts of electricity, often more than any other industrial process in the economy. By 1942, they were absorbing a significant portion of the nation's total electrical output. Electricity was being burned to produce fuel, which was then required to generate more electricity and move weapons that needed electricity to exist in the first place. The system fed on itself until it collapsed. A critical lesson lies in the role of political culture. In authoritarian systems, bad news is dangerous. Engineers and power station managers understood what was happening. They saw overloads, failures, and declining reliability. But information did not flow upward. Reporting limits was interpreted as defeatism. Acknowledging constraints meant challenging ideology. As a result, decision-makers operated in a distorted reality where production targets replaced physical possibility. When failures occurred, blame was assigned to individuals rather than to the system itself. The environment prevented course correction. A more flexible leadership might have slowed rearmament in the late 1930s, invested heavily in electrical expansion, and accepted lower short-term output for long-term sustainability. That choice was never politically acceptable. The regime was built on speed, spectacle, and the appearance of unstoppable momentum. Slowing down was ideologically impossible, even if it was strategically necessary. The Allied bombing campaign did not create Germany's electrical weakness. It exploited it. Once power plants, substations, and fuel facilities were targeted, the system had no resilience. There were no backups, no excess capacity. Every successful strike caused cascading failures far beyond the immediate damage. A destroyed transformer could shut down entire regions. A damaged power station could halt dozens of factories without a single bomb falling on them. This demonstrated a fundamental principle of modern warfare. Attacking infrastructure often yields greater strategic effect than attacking frontline forces. Collapse also reveals how misleading raw production numbers can be. German weapons output peaked in 1944, even as the electrical system was failing, but production without power stability is meaningless. Factories that receive electricity intermittently cannot operate efficiently. Machines stop mid-process. Skilled labor is wasted. Quality declines. Logistics become chaotic. By 1945, many factories technically existed but could not function as systems. They were shells without power. The fate of advanced weapons programs underscores this point. Jet fighters, advanced submarines, and new armored vehicles required precise manufacturing processes and stable electrical supply. These were the first systems to fail when power became unreliable. Germany possessed advanced designs, but lacked the infrastructure to produce them at scale or operate them effectively. Technological superiority means nothing without the energy base to support it. Deeper level, Germany's electrical collapse demonstrates that modern war is a competition between industrial ecosystems, not just armies. Victory belongs to the side that can sustain production over time, absorb losses, repair damage, and continue functioning under stress. The Allies, particularly the United States, built redundancy into their systems. They overbuilt power generation. They distributed production geographically. They accepted inefficiency in exchange for resilience. Germany did the opposite. It optimized for speed and output at the cost of durability. Also a broader lesson beyond warfare. Modern societies depend on invisible systems. Electricity is rarely noticed until it disappears. Economies, hospitals, transportation networks, and communication systems assume its constant presence. When planning ignores infrastructure limits, collapse does not arrive dramatically. It arrives quietly, through compounding failures that appear unrelated until it is too late to reverse them. Germany's defeat was not inevitable in 1936, but by choosing to subordinate infrastructure to immediate production, the regime locked itself into a path with no exit. Each decision narrowed future options. Each year of delay made recovery impossible. By the time leaders understood that electricity was the limiting factor, the system was already consuming more than it could produce. No reform could change that. The final lesson is perhaps the most uncomfortable. Willpower does not override physics. Ideology does not change engineering limits. Management cannot substitute for capacity. Systems obey mathematics, not belief. Germany lost the war not only because it was outfought, but because it was outplanned at the most fundamental level: energy. Lights went out across German cities in 1945. The war was already over. Not because soldiers stopped fighting, but because the system that sustained them had failed. And that failure began years earlier, with decisions that treated electricity as a background detail rather than the foundation of modern war. Is the real lesson of Germany's electrical collapse. Wars are won by those who understand their limits early enough to respect them, and lost by those who discover those limits only after crossing them. Another overlooked lesson of Germany's electrical collapse is how modern war punishes centralized thinking. Germany's power system, like much of its industrial structure, was tightly integrated and geographically concentrated. Major industrial regions depended on a limited number of large power plants and transmission hubs. This made the system efficient under normal conditions, but catastrophically fragile under attack. Centralization creates efficiency. It also creates single points of failure. When a major power station near Hamburg went offline, it did not simply affect one factory or one district. Entire regions lost power simultaneously. Assembly lines halted hundreds of kilometers away. Rail networks failed not because tracks were destroyed, but because signaling systems went dark. Communications broke down without a single wire being cut. The electrical grid acted like a domino network. Tip one piece, and the shock propagated everywhere. Allies understood this faster than Germany did. American and British planners increasingly shifted from factory-level targeting to system-level targeting. They did not need to destroy every weapons plant. They needed to destabilize the flow of energy. Once electricity became unreliable, the German economy began consuming itself just to stay alive. By contrast, believed that central control meant strength. Decisions were made at the top. Production quotas were dictated without regard for local conditions. Electrical dispatch was handled under extreme pressure, with engineers forced to choose which regions would receive power and which would be sacrificed. These decisions were often reversed hourly as emergencies shifted. The grid stopped functioning as a coordinated system and became a patchwork of crisis responses. reveals a deeper lesson about complex systems under stress. Once emergency management replaces normal operation, efficiency collapses. Systems designed for stability perform poorly in crisis mode. Germany's electrical grid was never designed for continuous triage. It had no mechanisms for graceful degradation. When it failed chaotically. Another critical insight is the difference between apparent output and usable output. German factories continued reporting production figures even as power shortages worsened. But these figures increasingly masked inefficiency. Machines ran sporadically. Workers waited idle for power to return. Quality suffered as processes were interrupted mid-cycle. Rework increased. Scrap rates rose. The economy appeared productive while actually hemorrhaging time and resources. The trap modern planners still fall into. Output metrics do not equal system health. A system can appear to function right up until the moment it collapses. Germany's war economy did not fail gradually in visible terms. It failed suddenly once instability crossed a threshold. When electricity became unreliable, everything downstream collapsed almost at once. There's also a lesson in how Germany misunderstood technological progress. Nazi leadership believed advanced technology could compensate for structural weakness. Jet fighters, advanced submarines, rockets, and new armored vehicles were pursued as potential war winners. But advanced technology increases dependency on infrastructure, not reduces it. Precision manufacturing requires stable power. Advanced materials require controlled processes. High-performance engines require uninterrupted testing and refinement. As electricity became scarce, the most advanced projects were the first to suffer. Simple weapons could still be produced intermittently. Complex ones could not. This exposes a harsh truth. Technological sophistication increases vulnerability unless infrastructure keeps pace. Germany built weapons for a future its energy system could not support. The more advanced the design, the more fragile the production chain became. Another lesson lies in labor utilization. Germany had millions of workers, including forced laborers, but labor without power is useless. Skilled machinists cannot operate silent lathes. Engineers cannot test designs without energized facilities. Training collapses when facilities cannot run regularly. The assumption that manpower could substitute for energy proved false. Contrast sharply with Allied strategy. The United States, in particular, treated energy abundance as a force multiplier. Factories were built near power sources. Redundant generation was constructed even when it seemed inefficient. Electrical overcapacity was considered insurance, not waste. When bombing or accidents occurred, systems absorbed damage without total failure. Germany's leadership never internalized this logic. They viewed infrastructure investment as secondary to weapons output. In reality, infrastructure was weapons output. Every shell, tank, and aircraft was merely electricity in solid form. Also, a psychological lesson embedded in the collapse. As electricity shortages worsened, morale deteriorated across every level of the system. Engineers faced impossible demands. Factory managers were blamed for failures beyond their control. Workers lost faith as machines stopped unpredictably. Trust in leadership eroded as reality contradicted propaganda. Systems collapse psychologically before they collapse physically. When people stop believing that effort leads to results, performance collapses. Germany reached this point by late 1944. Orders continued to flow, but belief in their feasibility vanished. This is a critical warning for any organization under extreme stress. Once credibility is lost, command authority becomes meaningless. Germany's electrical collapse also demonstrates how delayed consequences shape history. The decisions that doomed the grid were made years earlier. In 1936 and 1937, Germany could have slowed rearmament, expanded power generation, and built resilience. That window closed quickly. Every year of delay increased dependency and reduced options. 1943, Germany was no longer making choices. It was reacting. Reaction is not strategy. Reaction is survival mode, and survival mode cannot sustain industrial warfare. Another lesson is the danger of linear thinking in nonlinear systems. German planners assumed that doubling production required doubling effort. In reality, it required exponential increases in energy, logistics, and maintenance. Complex systems do not scale linearly. Small increases in output can require massive increases in support infrastructure. Germany ignored this reality until it was trapped by it. Collapse also reframes the role of bombing. Allied air power did not bomb Germany into submission in a simplistic sense. It exploited systemic fragility. Bombing worked because the system had no slack. A resilient grid could have absorbed damage. Germany's grid could not. Distinction matters. It was not bombing alone that won the war. It was bombing combined with pre-existing structural weakness. Without that weakness, bombing would have been far less effective. Final and perhaps most enduring lesson is that modern power, military, economic, political, rests on invisible foundations. Nations that neglect those foundations may appear strong right up until the moment they fail. Germany's armies were still fighting when the war was already lost. The collapse had occurred below the surface, in cables, turbines, transformers, and control rooms. Historians focus only on battles. They miss this deeper truth. The war was decided not just at Stalingrad or Normandy, but in power stations outside Essen, in overloaded grids, in engineers quietly watching gauges creep toward red lines that could not be crossed. Germany did not lose because it lacked courage. It lost because it violated the fundamental rule of modern systems. You cannot consume more than you can sustain. The lesson does not belong to the past. It belongs to every industrial society that believes output matters more than foundations, speed matters more than resilience, and will matters more than limits. History shows what happens when those beliefs collide with reality. There is one final layer to Germany's electrical collapse that deserves close attention: the illusion of control. Throughout the war, German leadership believed that central planning could compensate for physical scarcity. If electricity was short in one region, it could be redirected from another. If power plants were damaged, output could be optimized. If the grid was strained, discipline and sacrifice would fill the gap. Belief was fatal. Respond to ideology. They respond to load, frequency, voltage, and material limits. As Germany's grid approached failure, attempts at micromanagement only accelerated the collapse. Power was shunted unpredictably between regions, destabilizing frequency. Equipment designed for steady loads was subjected to constant fluctuations. Failures cascaded not because of single strikes, but because the system lost coherence. At this point, Germany crossed from shortage into instability. Shortage means not enough supply. Instability means the system itself can no longer regulate. Once instability sets in, recovery becomes exponentially harder. Germany reached this stage by late 1944. From then on, every intervention made things worse. It introduces a crucial lesson about complex systems. Beyond a certain threshold, more control produces less stability. Germany's leadership responded to crisis by tightening command, issuing more directives, enforcing stricter quotas. But centralized systems under stress require flexibility, not rigidity. The grid needed slack, redundancy, and downtime. It received none. Another overlooked consequence of the electrical collapse was the breakdown of coordination between different sectors of the war economy. Steel production depended on electricity. Ammunition production depended on steel. Transportation depended on electricity to move both. When power interruptions began, these sectors fell out of sync. Steel arrived late. Components piled up unfinished. Finished weapons lacked transport. The system stopped functioning as a chain and became a collection of broken links. Fragmentation destroyed efficiency faster than bombing ever could. It also explains why German production figures became increasingly meaningless. Output in one sector might rise while another collapsed. Total numbers concealed systemic paralysis. This is why Germany could report thousands of tanks produced while lacking fuel, spare parts, or trained crews to use them. Production became decoupled from operational reality. Modern war cannot tolerate that disconnect. It exposes the myth of total mobilization. The regime attempted to mobilize everything at once: industry, labor, science, transportation, fuel, and weapons. But total mobilization without prioritization leads to mutual destruction of systems. Electricity cannot simultaneously support every demand at peak levels. Choices must be made early, deliberately, and realistically. Germany delayed those choices until it no longer had any. By the time rationing became explicit, the system was already broken. Power cuts were reactive, not strategic. Factories were turned off without warning. Cities lost electricity in winter. Rail networks stalled unpredictably. These disruptions created secondary crises: food shortages, transportation delays, communication failures that further drained capacity. The grid was no longer supporting the war. It was collapsing under it. This brings us to perhaps the most important lesson of all. Modern warfare is constrained not by ambition, but by energy throughput. Every military system is ultimately an energy conversion process. Fuel becomes motion. Electricity becomes production. Heat becomes transformation. When energy flow cannot meet demand, the system fails, regardless of ideology, courage, or leadership. His leadership never truly accepted this reality. Hitler believed in decisive moments, miracle weapons, and final offensives, but energy shortages do not produce dramatic climaxes. They produce slow suffocation. Tanks stop moving. Radios fall silent. Factories flicker on and off. Wars are lost not with explosions, but with silence. The Battle of the Bulge illustrates this perfectly. Germany launched its last major offensive, believing surprise and determination could overcome material disadvantage. But tanks ran out of fuel. Trucks stalled. Logistics collapsed. The offensive failed not because of tactical errors alone, but because the energy system behind it was already exhausted. Early 1945, Germany was fighting a war it no longer had the power to sustain literally. The enduring lesson lies in comparison. The Allies did not win because they were flawless. They won because their systems were forgiving. Mistakes did not cause collapse. Damage did not cascade uncontrollably. Redundancy absorbed shocks. Overcapacity allowed recovery. Energy abundance created strategic freedom. Germany had no such freedom. Every loss was permanent. Every strike mattered. Every decision narrowed options. Difference defines modern conflict. The side with slack survives mistakes. The side without slack collapses under pressure. Electrical collapse also reframes responsibility. Germany's defeat was not the fault of engineers, workers, or planners at the technical level. They operated under impossible constraints. The failure was strategic and ideological. It began when leadership chose speed over sustainability, spectacle over structure, and belief over limits. Choice was never reversed. His electrical grid did not simply fail. It was consumed by weapons production, consumed by synthetic fuel, consumed by ideology, and once consumed, it could not be rebuilt in time. Berlin went dark in May 1945. It symbolized more than military defeat. It marked the end of a system that had devoured its own foundations. The final lesson is stark and timeless. Modern power is invisible. It flows through wires, systems, and processes that rarely appear in propaganda or speeches. Nations that ignore those foundations may rise quickly, but they fall faster. Not because they are weak, but because they demand more than their systems can give. Germany's war ended not when the last shot was fired, but when the lights went out. And by then, there was nothing left to save. Another way to understand Germany's electrical collapse is to look at what didn't collapse on the Allied side, not because the Allies were smarter in every decision, but because they built their war economies around abundance rather than optimization. This difference in philosophy mattered more than any single battle. Germany optimized everything. Production schedules were tight. Plants were pushed to maximum efficiency. Materials were allocated with precision. On paper, it looked impressive, but optimization removes slack, and slack is what keeps systems alive under stress. When the grid came under pressure, Germany had nowhere to bend. Allies, especially the United States, did the opposite. They overbuilt. Power plants generated more electricity than immediately needed. Factories were duplicated across regions. Supply chains were deliberately redundant. From a purely economic perspective, much of this looked wasteful. From a wartime systems perspective, it was decisive. One plant went offline, another compensated. When one region was bombed, production shifted elsewhere. When demand spiked, reserves absorbed the shock. The Allied war economy was inefficient by design and resilient because of it. Germany never accepted inefficiency as a strategic asset. This contrast exposes a fundamental misunderstanding at the heart of Germany's war planning: the belief that maximum output equals maximum strength. In reality, maximum output without reserves creates fragility. The German grid operated so close to its limits that even small disruptions caused outsized consequences. A single substation failure could halt dozens of factories. A delayed coal shipment could cascade into regional blackouts. In contrast, Allied systems could absorb loss without systemic failure. This is why bombing Germany had strategic impact, while bombing Allied industry rarely produced the same effect. The difference was not bombing accuracy, it was structural resilience. Another overlooked lesson lies in time horizons. Germany planned the war as a sprint. Even after it became clear the war would be long, decision-making remained short-term. Electrical infrastructure, however, demands long-term thinking. You cannot rush power generation. You cannot accelerate turbine construction without paying a price later. Germany continually postponed long-term investments to meet short-term production goals. Created a form of strategic debt. Stressed without expansion. Future capacity shrank. Equipment wore out faster. Maintenance backlogs grew. Skilled labor was diverted elsewhere. By 1944, Germany was paying interest on years of neglected infrastructure, and the bill was impossible to settle. Allies accepted early inefficiency to secure later dominance. Germany accepted early dominance at the cost of future collapse. History rewarded the former. Also a lesson here about scale. Germany attempted to fight a global industrial war with a continental energy base. It lacked access to large-scale oil reserves, hydroelectric capacity comparable to the Allies, and secure overseas energy sources. Rather than adapting strategy to energy reality, leadership attempted to bend reality to strategy. It works. Energy consumption exponentially. Aircraft production alone requires orders of magnitude more electricity than small arms manufacturing. Radar, communications, encryption, and logistics multiply demand further. Germany entered this era without the energy foundation to sustain it. The mistake is often hidden behind narratives of military genius or failure, but no amount of tactical brilliance can overcome an energy deficit at scale. Germany's most successful operations occurred early in the war, when energy demand had not yet peaked. As mechanization increased, energy constraints tightened. By the time Germany was fully mobilized, it was already energy bankrupt. Another angle worth examining is how electrical collapse reshaped decision-making under pressure. As shortages intensified, leaders were forced into false choices to power the cities or the factories, fuel the army or the railways, support civilian morale or military production. These are not strategic decisions. They are symptoms of systemic failure. Systems do not require such choices. Essential function survives. Collapse is already underway. Germany reached this stage in late 1944. From then on, every decision sacrificed something critical. No choice led to recovery, only delay. A crucial lesson for any complex organization. When leaders find themselves choosing which core function to abandon, the problem is not leadership, it is system design. This grid collapse also exposes the danger of believing that complexity equals strength. German engineering was world-class. Power plants were advanced. Industrial processes were sophisticated. But complexity increases dependency. Complex systems require stable inputs, continuous power, and precise coordination. When inputs become unstable, complex systems fail fast.